Hey, folks, this is a recap of the lesson that I went through today during A-Day lessons today. So these videos are intended for students that were unable to make it to class, that had maybe technical difficulties at the time. Also for those that just want to rewatch the lesson. Anyway, last week, Thursday, we began working off this document called Gears, Unit, Gears, and Proportions. And we've been learning around, really centering around a bicycle gears. Okay, so you've got your front gear here, you've got your back gear here. In your virtual lessons, you've been learning about something called gear ratio and mechanical advantage, what goes with gear ratios. So we started working off of this document and learning about parts of the bike specifically. In today's lesson, I showed a short YouTube video of a bike repair person, salesperson that talked about the proper way to shift, downshift, upshift your bike. I'm not going to show that video because I have noticed that showing the YouTube videos have been a little laggy today. So I'm not going to start with that frustration there. So I'm just going to go right into the document. So we spent about 3 or 4 minutes watching that video. None of it necessarily applies to this document. It was more or less just so you kind of understand these things conceptually. Anyway, so this is what we got done last week, Thursday. Answered questions 1, 2, and 3 on this document. Now, this document can be found in Google Classroom under assignments. Okay, so moving down here, we started understanding gear combinations. So we're going to pretend for a moment that we've got a gear combination that's got 1, 2, 2 large gears, one that has 30 teeth, and then another one that has 24 teeth. And then on the back end of the bike, on the rear, it has 1, 2, 3, 4, 5. Okay, the smallest one having 8 teeth, then 12, 16, 20, and then 24 teeth. So for this section, what you need to do is imagine and list as many possible combinations as we can come up with 30 or 24. Okay, 30 or 24, the 32-tooth gear or the 24-tooth gear. Okay, and then the other gears are 8, 12, 16, 20, and 24. All right. So how many possible gear combinations can we have with 2 gears in the front and 5 gears in the back? Well, if we multiply 2 times 5, we come up with 10. Okay. So 10 different gear combinations. So we've already done one for you. Okay. This next one, let's go with 30. Let's go with 8. Okay. And then that combination would be 30 and 8. All right. Now there's 8 other combinations you need to come up with, okay, using either 30 or 24. So we have 2 for 30 already. All right. We need to come up with 3 more for 30. All right. And then 5 for 24. So for instance, we'll make it simple, 24, okay, 8, and then my gear combination would be 24 and 8. So what you'll do is you'll work through and complete that table. Then in the next section, number 5, okay, is we're going to go with 24 teeth on the big gear, on the front gear, and then 12 on the back gear. So every time I push this pedal around one rotation, okay, one rotation, all right, it's going to be on a back gear that has 12 teeth. So something like maybe the size like this, okay? And each time that pedal goes around, how many times does the rear gear go around as well? Okay, so 24, if I divide it by 12, 12 goes in there twice. Okay, so it would be a 12 to 1. Every time that pedal goes around, every one time is going to equal 2 rotations of the back wheel. So again, how did I figure that out? The front gear has 24 teeth. Back gear has 12. 12 goes into 24 twice. That means every time this big wheel goes around, this big gear right here goes around once, this smaller gear is going to go around twice. Okay. So if my big gear, this guy right here, if this one goes around twice, all right, this one, it's got to go around how many times? Well, for one time, if it went around, this one went around twice, then this one would go around 4 times. So it's always double the amount of how many times this one goes around. So if the big wheel goes around, or big gear goes around 4 times, okay, small gear will go around 8 times. Okay, so then we worked on 5, we went through A, B, and C. Okay, scroll down here a little bit more. And we got number 6. We say the ratio of the number of teeth in the front gear to the number of teeth in the rear gear is equal to 12 to 2. I'm sorry, 24 to 12. When we put this ratio in its simplest terms, we call it the gear ratio. So that's all you're doing is you're taking the gear combination, and when you reduce it down to its simplest terms, okay, we get a ratio, and that is called the gear ratio. Okay, so we pick a number that's divisible by evenly by both. All right, so I could take 12. 12 goes into 24 2 times. 12 goes into 12 once. When the bike shop owner told Bianca, this goes back to the video on Thursday, about a speed gear, he was referring to gear ratios that cause the wheel to go around more times per pedal revolution. High performance bikes have chain wheel or freewheel combinations that include gear ratios of up to 5 or more. Okay, so a gear ratio, just talked about this. What's the gear ratio between 24 and 8? Well, our gear combination is 24 and 8. So I'm going to pick a number here. I'm going to put it in its simplest form. All right. So a number that goes into 8 and 24 would be 4. So 4 goes into 24 6 times. 4 goes into 8 2 times, but still not in the simplest form. So I'm going to go 2 goes into 6 3 times, 2 goes into 1 1 time. So my gear ratio would be 3 to 1. Means every time I pump 1 time on here, okay, this one's going to spin around 3 times. Okay, how many times does the rear wheel go around when the pedal goes around once? Well, 3 times. And then finally, thinking back to the earlier example, we were at a 2 to 1 ratio. So think of it this way. If I had this size gear and this size gear, okay, all right, as this one goes around, 1 revolution equals 2 revolutions here. Well, if it's at 3 to 1 and I only have 8 teeth, the gear is probably going to be smaller. So every 1 revolution here is equal to 3 revolutions here. So think about this. Would I be going faster at a 3 to 1 ratio or a 2 to 1 ratio? I haven't changed how hard I push down on the pedal. All I've done is change the gear ratio on the shifters. What would your answer be? So what we did in class today is give everybody an opportunity to kind of think about that, and the answer is 3 to 1 is much faster. Okay. Why is it faster? Because every time I push down on the pedal, I get 3 rotations out of the back tire. On the other ratio, if I were on the other ratio, every time I push down on that pedal, I only get 2 rotations. Okay. Then the in-class work or homework was to work on table number 7 here. It says complete the table below with the gear combinations for the bicycle that has 2 gears in the front, one of which has 30 teeth and the other 24, and 5 gears in the back at 8, 12, 16, 20, and 24. So a couple of these have already been done for you. Okay, 24, 8, here's my ratio or my combination, 24 and 8, reduced to simplest terms. I come up with every time I push that pedal down, okay, I'm going to get 3 spins or 3 rotations out of the back gear. 24, 12, 24 and 12, 2 to 1 ratio, which means Every time I push this pedal down right here, I'm going to get 2 rotations out of that back gear, which I'm going to rotate my tire 2 times. Let's do a different one here. Let's go 24 and 24, because that's one of my other potential combinations. 24 and 24. Reduced to my simplest terms, it's the highest common denominator, 24. So 1 to 1. 1 divided by 1 is, you guessed it, 1. So that means this and this are in line. So it means every time I do 1 pump of the pedal, it's going to turn my wheel once. Okay, I do this 33 times. It means I'm going to get 33 rotations out of here. Let's do one that's a little bit different, a little bit odd. Let's go to 30. Okay, and I put down 8. That's one of my potential combinations. So it's 30 to 8, or in its simplest form. So I want to pick a number that would be divisible by 2, the highest common denominator. All right, so let's try 2. 2 goes into 30 15 times. Oops, wrong column there. 15. 2 goes into 8 4 times. Now I can't reduce it any further. So how do I figure this out? Bust out my calculator here. I'm going to divide 15 by 4. And my result is 3.75. So 3.75. That means every time I push down on this pedal, I'm going to get 3 rotations out of my back tire. So that means I'm going to be moving pretty fast. Okay? Moving really fast. So your table is going to end up looking a little bit like this when you're finished. Okay. Oh, a little bit too far. A little bit like this. Okay. So a couple of them we've done already. That's what it's going to end up looking like. So that's what they worked on the rest of the time. Most of them got finished. When you are done with number 7 here, okay, that is the first assignment as part of this. So when you're finished, make sure that everything is complete. Go ahead and turn it in and submit. Look forward to seeing you in class next time I see you, whether it's an A day or a B day. We'll see you then. If you have any questions, shoot me a quick email. Otherwise, have a great day or night whenever you're seeing this.